Okay, this is the P4 paper from October 2020. This is question number 7, which is clearly an integration question. We've got integration by substitution up here, and we've got integration by parts down there. We'll do each part separately. Neither of them are particularly straightforward. Let's look at the substitution. Why isn't the substitution one straightforward? Because they haven't told me what substitution to make. So I could, if I wanted to, make one of two different substitutions. It's up to me which one to choose. I personally am going to go, well, this is the other one that I could do, sorry. I could take u equals the square root of 2x minus 1. That would get rid of that bit nice and simply. That would be u. You'd need to differentiate to get some sort of function for dx, and you'd need to rearrange this to get 3x, and obviously you also need to work out your limits. What I've chosen to do is, instead of doing that as my substitution, I'm actually going to do the substitution number 1. I'm going to say u equals 2x minus 1. So here, that part's going to be u to the half now on the bottom. Rearranging this to get 3x won't be complicated. My dx now becomes relatively straightforward to get, and so do my limits. Let's just go ahead and actually do all those things. Anytime I do any substitution question, it's always the dx part that I attack first in case it causes problems for anything else. It won't with my substitution. So if I do du by dx works out to be equal to 2, I can rearrange that then, and I'll get dx is equal to du over 2. So no problems with that part. If I want to rearrange, I'm going to get that x is equal to, what's that, u plus 1 divided by 2. So 3x is going to be 3u plus 1 over 2. So I'm sorted with that part. I'm sorted with square root of that. I'm sorted with that part there. The only bit really left before I start actually filling everything in is my limits. I always tend to do my limits on the right hand side here so I can see everything on my page. So for the limits, start off with x equals 5. So u will be equal to 2 lots of 5 minus 1, which is 10 minus 1, which is 9. If I have x equals 2, I'll get u is equal to 2 lots of 1 minus 1. That works out to be equal to 1. So now, hopefully I can fill everything in up there. Let's do it down here. We're going to say, okay, the question was the integral between 5 and 1 of 3x all over root 2x minus 1 dx. So if I replace those things, replacing the limits will be 9 and 1. Replacing 3x is going to be 3u plus 1 over 2. Dividing by root 2x minus 1, I'm just going to write that as 1 over square root u, and then dx gets replaced with du over 2. So I just now need to get this into some sort of thing that I can integrate. So first thing I'm going to do is take out 3/4, those ones, take out all of those. So I'll have 3/4 outside, and I'm going to have the integral between 9 and 1 of basically u plus 1 u to the minus a half du. So let's just finish off, let's just finish off multiplying that. So that's going to be 3/4 integral between 9 and 1. That's just going to be u times u to the minus half is going to give me u to the half, and then 1 times that is going to give me u to the minus half du. Okay, so if I'm integrating that, when I integrate that, add 1 onto the power, divide by the new power, is going to give me 2/3 u to the 3 over 2. Power will be u to the 3 over 2. Dividing by 3 over 2 is the same as multiplying by 2/3. I shouldn't really need to explain any of that to you. Same idea with the next one. Adding 1 onto power is going to give me u to the half, and dividing by a half is the same as timesing by 2. All between 9 and 1. So just however you want to evaluate this, what I'd actually do just to make this a little bit simpler going forward is I'd multiply that 3/4 out before I actually do anything else. 3/4 times 2/3 is going to give me a half u to the 3/2 plus 3/2 u to the half before I stick the values of 9 and 1 in as I'm doing that. And if I put those in, I'm going to get a half 9 to the 3/2 plus 3/2, lots of 9 to the half, minus, and then sticking 1 into that is going to give me a half 1 to the 3/2 plus 3/2, 1 to the half. I'm just going to tell you what the answer is here. Obviously, you can just go ahead and stick all those values in to see that it all works out okay, but it should come out to be equal to 16. So first part done. Second part, again, this is a complicated one. If you're not careful and you jump straight into the partial fractions, what you need to realise is that the order of this one, the power is squared there, and obviously x times 2x would give us squared there. So what we need to do before we can get started with our partial fractions is we need to make sure we've done the algebraic long division. So let's just say what the question is. The question is the integral of 6x squared minus 16 all over x plus 1, 2x minus 3 dx is what I've just got to do over here is to do this algebraic long division. So I've got 6x squared minus 16. I always tell my students, just put 0x minus 16 there. When you're doing the actual algebraic long division, that will just be a little bit easier to work with if I've got that 0 in there. X plus 1 times 2x minus 3, go away and do that. I've already done it. It's 2x squared minus x minus 3. So there's just lots of little nasty bits to this as we're going through trying to tidy this all up. So now doing the algebraic long division, how many times does 2x squared go into 6x squared? Well, it's nice and simple. It just goes in 3 times. 3 multiplied by all of this then is going to give me 6x squared minus 3x minus 9. We're now going to subtract that to see what we get left as our remainder. And we get the 6x squareds cancel, obviously. I get 3x there, and I get minus 7 there. So what I can now say is that the integral of 6x squared minus 16 all over x plus 1, 2x minus 3 dx is the same as the integral of, okay, so when we're doing this, it goes in that many times. It goes in 3 times. So it's 3, and then this is the fraction that's to the left. 3x minus 7 is a remainder, so it's 3x minus 7 all over. Now you could put it over 2x squared minus x minus 3, but we know that originally we had it written down like this. The only reason we multiplied it out was for the long division. So what I've now done is turned this integration into this integration, which I can now get on and get started with doing. But I can't yet. What I have to do, nearly there now with this one, is I've got to go through and change this by partial fractions. So lots of steps to this question, but it's kind of all relatively straightforward, I would hope you would agree with. So 3x minus 7 over x plus 1, 2x minus 3. You should have done hundreds of these in your preparation for the exam. So if I'm going to do that, this is some partial fraction, a over x plus 1 plus b over 2x minus 3. If we multiply out the left right-hand side, add together the fraction, that times that times that, and the bottom 2 times together. Standard stuff. We should get a 2x minus 3 plus b x minus 1 all over x plus 1, 2x minus 3. Well, that's the same as 3x minus 7 over x plus 1, 2x minus 3. So what we then say, notice I'm still going through nice and slowly doing all these bits. My next part is to say equate the numerator. Just get into a rhythm of doing these questions. Think about how you're displaying your answers every single time. I'm going to get 3x minus 7 then is equal to a 2x minus 3 plus b, sorry, that's like plus 1 there, I don't know where that minus 1 came from. B x plus 1 there. So if we're equating the coefficients, what I need to do is to just get rid of the a and the b. I'm going to do the simplest one first. If I let x equal minus 1 there, then I will get minus 3 minus 7 on this side is equal to a lots of minus 2 minus 3, that's minus 5. But the whole point there is that that part will be 0. So that's going to give me minus 10 is minus 5a, a is equal to 2. Then I'm going to choose x equals what? Well, what am I trying to do? Just really, really quickly, I want that bit to be 0, don't I? So if that bit's 0, I'm going to have to choose x equals 3 over 2. I don't do that as part of my answer. Let's just explain it to you guys. So if we say x is equal to 3 over 2 here, then I'm going to get 9 over 2 minus 7 is equal to nothing. That's the whole point. And I'm going to get 1 and 2/3. 1 plus 3 over 2. 1 plus 3 over 2 is 5 over 2. So I'm going to get 5b over 2 there. So tidying that up, b works out to be equal to minus 1. Quite happy to get those relatively simple numbers in there. So we've got that 3x minus 7 all over x plus 1, 2x minus 3 is the same as 2 over x plus 1 and then minus 1 over 2x minus 3 here. So if I want the integral of 6x squared minus 16 all over x plus 1, 2x minus 3 dx, that's equal to the integral of 3 plus 2 over x plus 1 minus 1 over 2x plus 3 dx. Now, as we're doing that, what I would just quickly do is go back and just check. Don't think they did. No, they didn't tell me anything here. That's, again, a nasty part of this question. They could have at least said show it's equal to some sort of format here, but they haven't at all. So all I now need to do is to go integrate each of those parts separately. So integrating 3 is 3x. Integrating 1 over x plus 1 would be log x plus 1. So 2 over it is going to be plus 2. Now, when we're doing this absolutely properly, that should be a modulus sign there. And then the same with the next one. It's going to be minus the log of 2x. Have I changed a plus to a minus again there? Yeah, I have to be really careful about that as I'm going through. Sorry, that's a minus there. 2x minus 3 here. But then because of the half, it's... Sorry, well, because of the number there, 2, that's going to be a half that plus my constant. And now they didn't say anything else about that, so I can actually leave that as my final answer. So I'm a little bit surprised they didn't just give me something to aim towards, but they didn't. So yeah, lots of places where you could go wrong with it. Quite complicated for both parts of that, but hopefully that all makes sense to you.